All right, where we left off last time is we had changed this original condition. We're looking for all the points where distance 1 is half as big as distance 2, or distance 2 is twice as big as distance 1. And we did the algebra, and we got this. And the question is, what is this thing? This does not look like a parabola the way that I thought it was over here. So what shape is this actually? So I hope that this is ringing some bells for you. This should feel very familiar. And the way that it should feel familiar is this looks a little bit like a circle. It looks a little bit like a shifted circle because we've got an x squared term and we've got a y squared term, except we've got some other stuff going on here. So here, let's move this down a little bit. Let's make one change to this to make it seem even more like the unit circle. So if you remember, equals squared 12. Okay, so if you remember, the unit circle equation is x squared plus y squared equals 1. Let's divide by 12 on both sides here so that we'll have a 1 on this side. So let's see, 4 divided by 12 is going to give us y squared over 3. 3 divided by 12 is going to give us this over 4. Okay, cool. So let's put a box around it again. All right, so now we've got some things we can compare. So in both cases, we've got an x squared term. In both cases, we've got a y squared term. In both cases, we've got a 1. So let's focus on the differences and ask ourselves, what are those differences about? So you tell me, what do you think? So here we've got an x squared. Here we've got an x minus 5 squared. So take a wild guess about what that one's about. I think you know this one. That's right. This is a rate shift by 5. So this is a translation by 5 to the right. Okay, so far so good. What about this divided by 4 and divided by 3? Like what could those possibly be doing? Maybe you'll think about it differently if you instead imagine it as a coefficient in front. So instead of x minus 5 squared over 4, it's like 1/4 times x minus 5 squared. So hopefully the feeling that you're getting is that these are scale factors. Because remember, if we've got, like some happy old thing like this, and I was going to multiply it by 1/2, that would be a scale factor on the parabola. So what's happening here is we do indeed have a circle, except that we're scaling it by different amounts in the x dimension and the y dimension. So take a wild guess. What happens if you take a circle and you scale it by a different amount in x and by a different amount in y? What shape do you think it turns into? Let's check it out in Desmos. All right, here we are. It might look like a circle at first glance, but it's very clearly wider than it is tall, which is explained by the fact that we're scaling by a different amount in x and y. So it's an ellipse. So we've actually ended up deriving the equation for an ellipse. And we'll be working more with the details of the ellipse equation in class, but sort of from a mathematician's perspective, what was interesting is, when these two distances are the same, you get a parabola. When distance 2 is twice as big as distance 1, it transforms the parabola into a completely different kind of shape, which seems very surprising to me. That's such a small change could have radically transformed the entire type of curve that you get. So if you're a mathematician, why don't you think about what's the next question you'd want to ask? What's the next thing you'd want to investigate about this scenario? Rest assured, we probably will. All right, good luck.